This is chapter 6, number 27. It says a 12-pack of Omnicola, mass 4.3 kilograms, is initially at rest on a horizontal floor. It is then pushed in a straight line for 1.2 meters by a trained dog that exerts a horizontal force with a magnitude of 36 newtons. Use the work energy theorem to find the final speed of the 12-pack. Question A, if there is no friction between the 12-pack and the floor, and we'll stop there for a moment. So we will start with our work energy theorem. So it is work equals 1/2 times mass velocity squared. We're going to change work into force times distance because we have those values. So Fd equals 1/2 mass times velocity squared. We have our force, distance, and mass. So we'll solve this equation for V and then plug in our values. Velocity equals square root of force times distance times 2 over mass. And then we can plug in our values. Here's a force of 36 times 1.2 times 2 over 4.3. When I plug that into my calculator, I got 4.48. meters per second. So that's our velocity with no friction. For part B, what we're going to do is we're going to use the same equation, but we're going to use our net work. I think that's the right word for it, our net work. So we have to find our work done from the force of the dog and the force of the friction, combine the two and plug it into the side of the equation. So, see, our net work done will be 3.6 times 1.2, which is the force done from the dog, minus the force from friction. It would be negative because if the friction's pushing this way and our object's coming that way, you get a negative force. So it's minus 12 point, let's see, oh, I never said what part B was. Says, so we need to find the final speed or the final velocity if the coefficient of kinetic friction between the 12-pack and the floor is 0.3. So we need to take that 0.3, well, let's start here. So our frictional force, we'll make that lowercase, equals your coefficient, 0.3, times the mass, which is 3.6, times our mass, which is 4.3, times gravity, change it to newtons. Do I have that right? I do. And when you multiply those together, you get 12.6 or 12.7. We're not well, let's go with it. 12.655 for your newtons. So this is the force of friction. Mixing up all my numbers here. So we have 36 newtons times the 1.2. Subtract your force of friction, 12.655, times 1.2, which then comes out to, it was 28.014. Now that is our net work done. And now we can plug that into our equation here and get our velocity. We have 28.014 equals 1/2 mass times velocity squared, multiplied by 2. So you divide by your mass, which is 4.3, and then you take the square root. And that would equal your velocity. When you do all that, it comes out to 3.61 meters per second. So it was a little bit jumbled, but I hope you could follow along. That is question 27 in chapter 6.